Hello everyone. In this video, we'll discuss Cramer's rule. And before going to the Cramer's rule, we should know how to find determinant because total Cramer's rule is based on determinant only. Suppose I have taken a matrix 3 by 3 matrix generally, and how to find determinant we'll see. So we'll denote by modulus of A like that. So let us take determinant. So first we'll take A here. So if you take A, delete the row and delete the respective row and column. So if you delete respective row and column, we left with E, F, H, I. So we have to take like this. If it is A, B, C, D, we have to take A, D minus B, C. So I'm taking E, I minus F, H. Next, so first with respect to the first row I'm taking. So next followed by minus B. We have to change the symbol, place minus plus like that. So if you take B, so we have to delete that row, that column and row. So if you delete that row and column, we left with the D, F, G, I. So again, so we'll get D into I minus F into G. Similarly, let us take C also. C of, if you delete the row and column, we left with a D, E, H, G, H. So we'll get D into H minus E into G. So I have taken some alphabets here. Let us take instead of alphabets, we'll take some numbers and we'll do it so that you can understand easily. Let us take one problem. Solve the following equations by Cramer's rule. So three equations are given involving the three variables. How to solve this one, we'll see. Okay. Listen here. First, whatever the equations are given to you, from that we have to make the matrices. So let us take first A matrix. How do you get matrix A? So from the given equations, I will get. So take the coefficients. Take all the coefficients of the variables. Like here, x coefficient is a 2, first row. Y coefficient is a 1. Z coefficient also 1. Similarly, you can write the second row. That is a 1 minus 1, be careful with the symbol, and 3, and finally minus 1, 1 and 1. So this is the matrix A, and the next X matrix will be there. We have to find the values of X, Y, Z only. So X matrix will be there like small x, small y and Z. This is the matrix X, and we'll be getting one more matrix with the name D. So how do you get matrix D? This is nothing but all the RHS values of the equation. So that is 5, 6, 2. So this is the first step after giving three equations in the question. So we have to make this matrix first step. Matrix A we got from the equations. Now we have to find the data. Determinant is also denoted with the small capital D or delta also we can use. So already we have taken D. So let me take delta for easy calculations. I'm taking delta to avoid the confusion with the D and delta. So how to find this data? As we discussed the formula, here we'll go with the numbers. So let us take first 2. If I take 2, so we have to delete this row and column. Minus 1 into 1 will get a minus 1. Minus 3 into 1 will get 3. Next, minus 1 of, so delete the second row, second column and first row. So 1 into 1 will get a 1. So minus 3 into minus 1 will get a, 3 into minus 1 will get minus 3. Already minus will be there, so it will become plus 3. Similarly, 1 into 1 minus, anyways it will become plus 1. So 1 minus 1. So this will become 0 anyways. So how much are you getting? This is nothing but minus 4 into 2 minus 8. This is 4. 4 into minus 1 will get a minus 4. Anyways, this is 0. So the data, how much we got data? That is minus 12, which is not equal to 0. Remember, whenever data is not equal to 0, we'll get solution for sure. If data is equal to 0, we won't get solution. We got data. How to find the x, y, z values? Suppose actually the formulas are given like x value is given by det1 by det. Sir, already we got data. How to find det1? I'll tell you how to find that. And y value is given by det2 by det, and similarly z value is given by det3 by det, or delta. Determinant, nothing but short form for the determinant det. Now how to find det1? So we got delta value. How to find delta 1? So to find out the delta 1, from the matrix A first column, we have to replace the first column with the elements of D matrix. Replace the first column of the matrix A with 5, 6, 2 elements of matrix D. Right, we got next new matrix A1. by replacing the first column with 562, and this is a matrix A1, so we did the same, replaced the first column with 562. Again we have to find a determinant for this. How do you find determinant? Same formula. Now let us take a delta 1. Okay, now delta 1 is equals to, let us take the same formula, 5 into minus 1 minus 3, and minus 1 into 6 into 1, 6 minus 3 to the 6 again, and plus 1 into, so if you remove the last column, third column and first row, we will get 6 into 1, 6, minus is there, it will become plus. Remember, whenever 1 minus is there, it will become plus, and if it is having both are minus, it will be having same symbol like that. In a easy way you can remember. Do simplification, minus 4, 5 4 is 20, this is a minus 20. Anyways, this will become 0 and you can ignore that. And here 8, it is 8. So how much are getting? Minus 28, nothing but we'll get a minus 12. So this is a delta 1. So we obtained from matrix A1. Now we have to find delta 2. How do you find, how do we find delta 2? Same process. So previously we replaced first column with 562, that is matrix D, we got A1. So now replace second one. Okay, now for the third matrix, we have to replace third column like that. So if you replace that, I will be getting A2. We'll see that. Right, this is a second matrix. We replaced the second column with the matrix D, that is elements 5 6 2. Same again, let us find a delta 2 for this one. So what do we get? A 2 of 6 minus 6 again, and minus 5 into 1 plus 3. You can check the formula if you want, and plus 1 into 2 plus 6. Okay, how much are getting? 6 minus 6, anyways it will be 0, you can ignore that. And 4 5 4 is 20, minus 20, that is, and this is 8 again. So minus 20 plus 8 already we got, that is minus 12. So delta 2 also we got minus 12. Let us go with delta 3. Again we have to get matrix A3. For that, as we discussed, we have to replace the third column with the elements of matrix D. This is a third matrix. We replaced the third column with the 562. This is a 562. Okay. So in the first matrix, we replaced the first column, second matrix, second, and the third matrix with the third column. Now let us find the delta 3 for this. If you find delta 3, same process, apply the formula, 2 into 2 into minus 2 minus 6 minus 1 of uh, 2, and it will become plus 6, and place 5 into 1, and both are having minus, so you can write 1 minus 1. So if you know the formula, if you are doing more problems, you'll get easily. Like for the first one, we deleted the respective row and column. So minus 1 into 2 minus 2 minus 6, AD minus BC. Similarly, minus 1, next place minus place. So we have deleted respective row and column. 1 into 2 2, 6 into minus 1 minus 6, that is already minus it become place. Now 5, 5 into 1 into 1 1, and minus again will get anyways plus 1, so minus 1 like that. AD minus BC. How much are getting? Minus 8 to the 16, minus 16 it is, and here 2 plus 6 8, and minus 8, 1 minus 1 0, you can ignore that. How much are getting? Minus 16 minus 8, that is nothing but minus 24, minus 24. Now we got three date values, and date 1, date 2, date 3. We have to find out xyz values. So first I'm going with x value. How do you get x value? X is equals to, as we discussed, delta 1 by delta. How much we got? Delta 1. Delta 1, if you remember, starting I explained delta 1, sorry, delta is a minus 12, starting we got, and delta 1 here only it is there. How much we got? Minus 12 again. So minus 12 divided by minus 12, so it will get cancelled, we'll get a 1. X value is equals to 1. Similarly, let us go with the y value, delta 2 by delta. Same, delta 2 also we got minus 12, minus 12 by delta also minus 12, so you can cancel this, again we are getting 1. Coming to the z value, that is delta 3 by delta. The delta 3, how much we got? Minus 24, minus 24 by minus 12, so minus minus we can cancel first. 12 ones are 12 twos are, so z value become 2. Therefore you can write x is equals to 1 and y is equals to 1 and z is equals to 2. So this is the solution finally, x, y, z. So Cramer's rule is used to find the values of x, y, z of a system of linear equations, and we can check it whether our answer is correct or not. We got 1, 1, 2 in a given equation. In a given equation, any one of the given equation you can substitute. You can take any equation. Suppose I'm taking the first equation, substitute the values x, y, z values, you substitute. So what do we get in the first one? 2 into 1 and y value also 1. Z value how much we got? 2. So 2 plus 1 plus 2, that is nothing but 5. So you can check it like this. As it is same as RHS, so our answer is correct. Not only the first equation, you can substitute in any one of the equation and you can check it. Suppose I'm taking third equation, minus 1 minus x nothing but plus 1, z value we got 2. So minus 1 plus 1 cancelled, so 2, right? So like this you can check it with the second equation also, any one of the equation. Okay, like this you can verify your answer. Okay, thank you.